All right, monochromatic light falls on a slit that is 0.00320 millimeters wide. Whoa, it's getting down there, right? That's like, what, 3.2 micrometers or something like that, right? The angle between the central maximum and the second dark fringe, so that's the angle here to here, okay, is 18 degrees on one side. What is the wavelength of the light used? I think I can do this. All right, I can do this. Okay, so we don't know the wavelength of the light, but we do know that D is 0.00320 times 10 to the minus third meters. And we know that that angle is 18 degrees, right? Okay, so I'm going to say D sine theta is equal to, and it's the 1, 2, it's the second guy there. So it's really 2 lambda. Second dark, yeah, 2 times lambda. Okay, so the wavelength is going to be just that, right? Is it that easy? It can't be that easy. Let's try it. Okay, so 0.00320 times 10 to the minus third. Let's just try it. Maybe it will work. Sine, make sure you are in degrees. 18 degrees divided by 2. Let's try it. I can do it. 0.0032 e minus 3 sine of 18 divided by 2. Ooh, I think I did it. I think I got the right answer. Lambda is equal to 4.944 times 10 to the minus 7th meters, which is 494.4 times 10 to the minus 9th meters, which is 494 nanometers. Wangy. All right, baby, we got it.